Hi oceanography students. This short video is going to help you with your ocean waves field trip and help you answer the questions on the pre-lab exercise. Dolphins figured out that waves are fun long before people ever did. Dolphins are really the original surfers. But people eventually figured it out too, figured out that waves are fun. And waves can also be dangerous. And therefore there are a lot of good reasons to study the science behind waves and to understand their behavior. And this is what we're going to be doing on our field trip to the pier. We're going to be measuring waves that formed far out at sea, probably formed by big storms. And we're going to try to understand how those waves changed as they went from the deep water into the shallow water where we're going to see them and where surfers are riding them. Now, some basic wave measurements you need to understand. Wave height is the vertical distance from the trough of the wave to the crest of the wave. Wave length is the horizontal distance from one wave crest to the next wave crest. And then wave period is a time measurement. It's the time between two successive wave crests measured in seconds. And you're going to be making this measurement at the pier. When one wave crest comes by, you're going to be starting your stopwatches. And when the next wave crest comes by, you're going to be stopping your stopwatches. And that will be a measure of the wave period. And just so you know, typical wave periods for ocean swells arriving at our beaches in Southern California, 12, 13, 14, 15 seconds. Those are the kinds of numbers that you can expect to get. Now this graph shows us an important relationship between the wave period and the wavelength and the wave speed. And basically what the graph tells us is that waves with longer periods are also have longer wavelengths and also move faster. And this turns out to be a useful relationship because the wave period is a fairly simple number to measure. Now this is the relationship that we find when waves are out in deep water before they slow down near land. And so, for example, if you were to measure a wave period of 14 seconds, that corresponds to a wave speed of about 22 meters per second, or say 70 feet per second if you go over here. And a 14-second period also corresponds to a wavelength of a little over 300 meters, or say about 1,000 feet. So the message from the graph is that longer wavelength waves with longer periods also move faster. This turns out to be important because most waves are formed by big storms far out at sea. And what happens is when you go to a storm, it's a very chaotic ocean where many waves are moving out from the storm. But the waves aren't all moving at the same speed. The faster waves with the longer periods and the longer wavelengths are moving out ahead of the slower waves with the shorter periods and the shorter wavelengths. And so if you let those waves separate from one another, and this process is called dispersion, waves separating according to their speed, period, and wavelength. What happens is if you go away from a storm, let those waves travel, they'll separate and form very uniform groups of waves that we call ocean swells. You can see here the distances between the crests are very, very regular. And that's because they've all been traveling at the same speed because they all have the same period and wavelength. And so when those big swells arrive, say, at the coast, they begin then to change in a particular sorts of ways that we're going to try to understand. A very important number that you want to know and understand is called the wave base. This is the depth at which the orbital movement of the waves begins to feel friction with the bottom, and that forces the waves to begin to slow down. The wave base is a number that is a depth of water that is equal to 1/2 the wavelength. So for example, if you have waves with a wavelength of 500 feet, their wave base is going to be half of that, or 250 feet. That's the depth at which they're going to feel friction with the bottom and begin to slow down. And as waves slow down in shallow water, and by shallow water I mean water deeper, shallower than the wave base, their wave speed decreases, and that causes their wavelengths to decrease. The waves begin to bunch up as they catch up to each other. You can see on this picture how the waves kind of squeeze together. The squeezing together of the wavelengths causes the wave heights to increase, which is what causes them to eventually break. But an interesting thing is that the wave period actually stays the same. So when you measure the wave periods at the pier, those waves had the same period when they were far out at sea in deep water, and that'll be useful for us to be able to use that number to figure out some things about the behavior of the waves when they were in deep water. So I hope you have a good time at the pier and see some beautiful waves and get some good measurements, and don't forget your surfboards. Have fun.